So in this video, we want to look at the application of dimension. How important are dimension in physics or in science as a whole? And so that's what I'm going to talk about in this video. So first of all, dimension, it is used to verify the accuracy or validity of an equation. My equation is quite small. Just pardon me that. Okay, so we use dimensions, the knowledge obtained or gained in dimension, or helps us to actually check the accuracy of an equation. So there is this principle, homogeneity principle. I think I have to spell it well. Let me use different. Okay, so there's this principle, homogeneity. Yeah, that is the right word. And it says that the dimension of the equation at the left hand side. So the dimension of the equation at the left hand side should be equal to the dimension of the equation at the right hand side. So RHS. So this is what this rule says. So if that is true, then whatever equation we have, we can use dimension to verify whatever we have at the left side is the same as whatever we have at the right side. So first of all, let's look at this first equation. Let's pick yellow. So our first equation, we're looking at our favorite, or let me say popular equation. Energy is equal to what? mc square. Good. We already know that the dimension of energy is equal to in this case it's energy, that's the same as work. So we have ml square t square. So that is the dimension, so we can put it in a square bracket, of energy. But we know this as what? M. So m is just mass, so the mass of an electron times the speed of light. So this is actually speed. C is speed. C is what? Speed. Speed. Let me write it well. So C is speed, which has a formula of the dimension of LT neg 1. We have already looked at that in the first video. So if we should bring that one here, then we will have our dimension over here to be LT to the power -1. Okay, but there's a square here, so let's square both of them. So we'll have ml square t square equal to ml square t to the power -2, because 2 will multiply this will give us -2, and 2 will multiply this give us +2. So by dimension, we can boldly say that the dimension at the left hand side, that is energy, is equal to the dimension at the right hand side, that is mc squared. So by this we can say that this equation is what? Valid, or is what? Accurate. Now let's look at another equation for motion in a straight line. That is, we have v square is equal to u square minus 2as. So v is final velocity, u is initial velocity, a is acceleration, and then s is distance, or distance covered. So now let's find the dimension for this equation. So at the left hand side we have dimension of velocity already is L to the power so L to the power -1. So that is it for this one. And then we have this one too is a velocity. So but there's a square here, so let's bring it. And then we have L to the power negative 1, not 2, to the power 2 minus 2 times the the distance of our acceleration, dimension of acceleration is Lt to the power negative 2, and then we have our L, that is dot L. So we'll have L squared T neg 2 equal to L T neg 2, that will be square here. Okay, so that is it for this one. Then minus 2, because L is here, they all have power 1 1, so we just have to add the powers, that is 1 1, which will give us 2 T to the power negative 2, and then we'll have L 2 T to the power 2 equal to 2. So this is the same as this, so we will maintain that. So we have 1 here, we have 2, so we have 1 minus 2. Okay, 1 minus 2, 1 minus 2, and then that will give us negative 1 L. So let's not bring negative 1, so negative L, so put it in square brackets, negative L squared T to the power neg 2. So you can see that the dimension at the left hand side is the same as the dimension at the right hand side. So we can say that this equation 2 is valid. You see, we are not too much concerned with the negative. Ours is the dimension. So the homogeneity principle says that the dimension of the left hand side of the equation should be equal to the dimension of the right hand side of the equation. So our focus is on the dimension, not really the numbers that comes in front of the numbers or that comes with the that's the coefficient. We are not interested in the coefficient. Our interest is to make sure that the dimension is correct. So as soon as you get the dimension to be so, it means that whatever you have here is correct. Over here you can just compare, so you can see that this dimension is the same as this, and then this dimension too is the same as this. So over here you can even conclude that this equation is what, valid or accurate. Okay, so that is how we use dimension to check the accuracy of equation. I think we should check another try another equation and see. We should try another equation. So let me clear this part and then let's try another equation. Let me clear this part and then good. So now let's try another equation and see. So we have another equation of linear or motion in a straight line, which is x. So the distance covered by a body with initial velocity u in a time of t. So t minus, so here it can be minus or plus depending on how the equation is being viewed, 1 over 2 at squared. Okay, so we want to find the dimension of this equation, like check whether it is dimensionally accurate. Okay, so now let's use our dimension for s. S is what, L. So this will be equal to dimension for velocity, which is Lt neg 1. We can put it in a square bracket for now, and then we'll have t, positive t, so dot positive t minus 1 on 2 dimension for acceleration is Lt neg 2. Then we have dimension for t, because it has square, we square it. Okay, so what will be the resulting? What will be the result? So L will be equal to, so you have t here, you have t here, so 2t, so Lt minus 2t then minus 1 over 2 L. So here there is square, so we need to bring the square here. LT square. Okay, so L square T square L square T square. I hope that is correct. Okay, here you see the power is 1 and here is negative, so when you add the powers it will be 0, so we'll have here to be what? L. So here is not LT, here is only L. Let me clear that as well. Here will be only L. Okay, so we have L here minus this, so you have 2, this is negative. Okay, this is negative, so let's take note of it. Then we have our T square. So you can see that here too we have L square minus no, there's no minus here. There's no minus here. AT square. Okay, velocity is not squared, so that's where the mistake is coming from. Please, let's try and go over that again. Let me clean this aspect and then let's go over. Let's go over again and see if we can get something. Okay, so let's write it all over again and then. So we have dimension of here S to be L, and then we have LT dot T. Let's do away with the brackets now. Minus 1 on 2 LT like 2 dot T 2. So here there is neg 1 here and then there is plus here, so you have L to be equal to L minus 1 on 2. This is positive, this is negative, so we will have T neg 2 plus 2. Okay, and this will give us T to be equal T2. This will give us okay, so our T will become 0 and our L will be L. So finally we'll have T to be equal to L minus 1 on 2 L, because this is 0. So if we should look at this, the dimension here is the same as this, and then the dimension here is the same as this. If you want to go further, you can have, so this is half of it subtracted from 1, which will have a 1 on 2 L. So our final answer will actually be, this is our final answer, L, put it in a square bracket, is equal to L in the square bracket. So this is our final answer. So we can also say conclude that this equation is what? Valid. It's valid. This equation is what? Valid. So this is how we can use dimensions to check the accuracy of an equation. So there are lots of equations. Please find a few of them and then try your hands on them. That's it for this video. Please subscribe to this channel and then click the notification button. Anytime I load video, you'll be able to have access to it. You'll be notified to watch. Thank you.